stable form, they combine together. When you see just the element, like no subscripts, just I'm not giving you the definition, I'm saying it in like simple words, that if you just see the element like O, Na, He without any subscript like 2 or whatever 2, 3 written, that will be the atomic mass. Then there is something else which is known as molecular mass. This is what mostly you will be calculating. But in the question, you are always given the atomic mass. So they'll give you things like this separately. They'll give you something like this. Like they'll give you atomic mass of hydrogen is 1, oxygen is 16. Okay, then they'll ask you calculate the molecular mass of water, of H2O. Right? So what you do is, just a second.
Miss,
So what do you do is, yes, tell me.
Miss, your voice is lagging a bit.
Oh,
Yes, ma'am.
is it? So they ask you to calculate the molecular mass of H2O.
Miss,
So
Ma'am, are you
still,
trying to say
that you will do
something?
as
I cannot hear you. Because yeah, ma'am, it's lagging a lot.
Yeah, absolutely.
okay.
Miss, I think you should rejoin again so that your voice just.
Okay, this it should be better now. Can you hear me? Am I audible now?
Miss, still your.
Ma'am, are you trying to say something?
Oh, yes. Can you hear me?
Miss, still your voice is lagging, but now it's okay.
It's better.
Better?
Yeah.
Okay.
Yes.
Okay, fine. Okay, so I was talking molecular mass, correct? Where I was saying in the question generally they give you the atomic mass, like they'll give you the atomic mass of hydrogen is 1U and oxygen is 16U. Okay, and they'll ask you to calculate the molecular mass of water. So in that what you do is you multiply, like it's H2, so you need to take into consideration both molecules of like both atoms of hydrogen which make up the hydrogen molecule. So 2U1 plus it must be just a second. Plus 16, right? So 18. So the unit of atomic mass is nothing but U, okay? And it's same for molecular mass expressed as U or AMU is what it's called, or simply U, any of the two. Okay, so molecular mass comes into play whenever I give you something like calcium carbonate, CaCO3. So you will consider Ca as 1, Ce as 1, and oxygen as 3. 3 atoms of oxygen are there which combine to form this oxygen molecule. So you need to consider all of that. Correct? Okay, so that's molecular mass. Now there is a third term which is known as formula unit mass. Somebody was asking on the group yesterday, isn't it? What is formula unit mass? Okay, so formula unit mass is nothing but the molecular mass, okay, for ionic compounds. That's the only difference. Okay, if they ask you the difference between molecular mass and formula unit mass, you need to know that formula unit mass is for ionic compounds only. Just remember this keyword, ionic compounds. Okay, what are ionic compounds? Any compound which splits into corresponding cations and anions, like NaCl. NaCl is an ionic compound. Why it splits into Na plus and Cl minus. Okay. So these are the basic three terms. Get this very clear because the question they'll give you actually they provide the atomic mass, but while calculating number of moles you need to find molecular mass, and in some questions they ask you separately for formula unit mass. So keep all these three things in your mind. Okay. So okay, cool. We're done with this. Now coming to the mole concept. Okay. So in mole concept, I was telling you last time a few things, right? In last class, like it's a unit. One mole is like a unit defined by chemists to make chemical reactions easier. So calculations in chemical reactions, if you consider this simple reaction of H2 plus O2 giving you H2O, isn't it? If I balance it. So what can I say about this reaction? I can say two molecules. Okay, why am I saying two molecules? Because H2 is a molecule, isn't it? So, and I'm putting a 2 in front of that. So two molecules of H plus one molecule of O combines to give me two molecules of uh, of water, correct? So in these kind of chemical reactions, like this is the most simplest one. As you proceed ahead, there are chemical reactions which have a number of compounds or which become tedious to calculate. So for easing all these things, they develop this new unit which is a mole. Okay, this unit. Okay, and the mole has a fixed number of particles, which is nothing but 6.022 into 10 to the power 23. And this is known as the Avogadro's constant or number. Okay, so like remember something like this, like okay, in the textbook they have given you for an analogy, they are saying something like 1 dozen is 12, right? We call 12 anything which is 12 bananas, like just predefined. So keep
Miss,
this
your voice is
Ma'am,
in
your
lagging.
mind.
voice is lagging.
Voice is very
Okay,
lagging.
okay, okay. It is
Ma'am, still it's lagging.
Yes, ma'am.
okay. Can you hear me now?
It's lagging.
Miss, it was still lagging.
Still, ma'am.
It's very much lagging.
Now is it better?
Yeah,
Yes,
miss.
ma'am.
Yeah.
Awesome. Okay, so I was telling you that in your textbook they have given an analogy of dozen, like 1 dozen is 12 of anything, like 12 apples or 12 bananas. Like that, one mole is 6.022 into 10 to the power 23. They call it entities. Okay, this is fixed. Always remember this. Okay, so now what is entity basically? Why they are saying entity is because one mole can equal to 6.022 into 10 to the power 23 atoms or molecules or ions and particles, any of these. Okay, this depends on the context you are looking at. Based on that, you can say it is any of these. Okay, so just keep this in mind. Keep this Ma'am, are you
Ma'am,
saying anything?
yeah, ma'am, I can't hear you.
I too.
Yeah, miss, we can't hear you.
Ma'am, ma'am, are you saying something?
I think Miss left the meeting.
Sorry, I got disconnected. Let me just present my screen. Okay. I hope I'm audible.
Yes,
Yes,
ma'am.
ma'am.
Okay, fine. Okay, so I was telling you that these two formulae are the key formulae you need to remember. Okay, one is the given mass by molar mass and number of particles by Avogadro's number. So, and I was also telling you that molar mass is nothing but the molecular mass. So now you know the difference between atomic mass, molecular mass, and formula unit mass. So hope there is no confusion in that.
Ma'am,
Yes.
ma'am, could you actually explain the last part because we couldn't hear you before you got locked out?
Oh, okay. I'm so sorry. Okay, I'll tell you again. Okay, so basically 1 mole is 6.022 into 10 to the power 23 atoms or molecules or ions or particles. Why have they given these many terms is because it depends on the context, okay? The context of your chemical reaction. Like for example, if I am talking about, I'll write it here. Okay, I'll take the example of water only, water formation. Okay, if I talk about this case, I can say that uh, if I am okay, if I consider it as if I'm considering hydrogen, let's say, okay, so I can say 2 moles of hydrogen molecule are involved in the reaction, correct? 2 moles of hydrogen molecule. Or what can I say? Or I can also say I can go ahead to make it hydrogen atoms, okay? Or if this was splitting of water molecules, I could have made it ions. Okay, it's like that. Like you can consider it as molecules or atoms or ions or particles. Hence these definitions. Okay, and then I was telling you that there are two important formulae which are required in this concept. One is number of moles is given mass by molar mass, and the other is number of particles by Avogadro's number. So the second one is used whenever they ask you, when they ask number of particles. They'll ask you direct questions. Mostly, it's everything is direct. It's not anything twisted. So that's when you use this. Or if you see anything like 10 to the power something in the question, okay, 10 to the power, let's say 20 or whatever, any number, automatically means you need to use the second formula because you get Avogadro's number as the denominator, which is 6.022 into 10 to the power 23. So they'll give you something where the powers will get cancelled. Okay. And yeah, so molar mass is nothing but molecular mass. Okay, so this is all I wanted to go through once again. Now we'll take up your questions, your doubts, and let's solve. Okay. Okay, so let's start with. mm, So you have level 1 and level 2 questions, right? For your homework you had. So first question is easy, is direct definition. Second also. Anybody has doubts in the third one? Write down the formulae of sodium oxide, aluminum chloride.
No, miss.
No?
No doubts.
Is it clear? Okay.
Ma'am, level 1 was given as
Uh,
homework, right?
yes. So I'm discussing your homework only. I'm not doing anything else. Nothing new will be done. Any doubts which you have in the homework?
No, miss, I don't have any doubts. I just wanted to know about, I just wanted to understand that exchange of the metals formulas, that one, when we exchange the diagram.
Okay, that. Okay, fine. I'll tell you. Okay, so let's take an example then. Wait, I'll tell you with the example. Mm, yeah, okay, the ninth one, right? The chemical formulae of the following. Oh, that is also direct, no? Okay. Let me see. Okay, I'll show you with that. So the ninth one, right? The chemical formulae of the following. It says magnesium chloride, right? First one is okay. So here there are what are the key points when you write the formulae? First thing, the metal comes first. Metal before non-metal, always. Correct? And what is the second thing? You exchange the valencies, isn't it?
Yeah, miss.
So if I talk about magnesium chloride, magnesium is Mg and this is Cl. Yeah, Mg is 2 plus, Cl is 1 minus. Okay. So how do you write this? Okay, how have they done it? Okay, so basically they write it like this. So they write it down. They write the valency below this. And what do they do is just to show how you get the formula. So this valency of plus 2 will go to chlorine and this valency of 1. They don't take into consideration the power. So it will be just 1 which will go to Mg. So what will be your formula like? It will be MgCl2. Okay. Then what would be the next one? Okay, this is interesting. It's copper nitrate. Copper nitrate. Right. So for this it's Cu and what is nitrate is Mg. Okay, so it will be Cu2
Miss,
plus.
Ma'am, your voice is cracking.
yeah, lagging a lot
Oh,
between.
is it fine now?
Yeah, miss, better.
It's better. Okay. Okay, so I was saying as a valency of 2 plus, so I'll just write 2 here and NO3 is 1 minus again. So this goes here and this goes here. This is how you write it to exchange it. Or do they ask you questions to show this diagram of exchange?
Yeah, miss, in the homework they asked us.
Okay. Okay, then fine. Okay. So this will be like Cu and because there's already a subscript for oxygen, like it's O3, hence NO will be written in the bracket NO3 and then this is the formula for copper nitrate.
Miss, in exam this may come.
Yeah, but they might not ask you to show the exchange of valencies. They'll just directly ask you to
Miss, your voice is lagging.
Yes, ma'am.
okay. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay.
Now,
So I was saying I'm not really sure about this exchanging part diagram, like this valency exchange if they ask, but they will ask you to write the chemical formulae for compounds. That is, yes, that is a question which will come. Like they'll tell you magnesium chloride, you need to come to MgCl2. They tell you copper nitrate, you need to write this. Okay. Okay, so you got the idea, right? What you need to do.
yeah, miss. Thank you.
Okay. Then there is this question. Okay, so the seventh one, calculate the formula unit mass of, they have given you ZNO, Na2O, K2O, K2CO3, and they have given you atomic mass. See, this is what I was trying to explain. That they are asking the formula unit mass, but they have given the atomic mass. So what is the formula unit mass? It's nothing but the molecular mass. So for ZNO, you'll just add for Zn and you'll add for O. For Na2O, you need to take this 2 into consideration. So what will it be? It will be 23 into 2 plus the mass of oxygen, that is 16. Does anybody want me to solve this question?
No, ma'am.
No,
No?
miss.
Okay, fine. Then let's go ahead. Okay, all these, the others are easy. Let's see mole concept formula.
Ma'am, polyatomic
Okay.
ions will be basically the ions will have four valency, right?
Yeah. So it'll be, yeah. It's anything which has more than three, like yeah, 4, 5, anything. But they're asking what are polyatomic ions. Okay. Okay. So in this case, polyatomic ions will be something like minus one also. So you can consider things like phosphate. No, phosphate will come in three. Uh, Ammonium, maybe NH4. Example I can come up with. This will be a polyatomic ion. So ion, it can be positive or negative. So it has four or anything beyond that, like that. Okay. Uh, which question did you all have as homework? Just check.
Miss, I think the whole of level 1 and half of level 2.
Okay. So okay, yeah, there's one question. Okay, the 31st question. A 4.0.08 gram sample of compound of oxygen and boron was found by analysis to contain 0.192 gram of boron and 0.288 gram of oxygen. Calculate the percentage composition of the compound.
Miss,
Yes.
are you sharing the screen? Because I can just see the black screen.
She is
Oh,
correct.
I
Yeah.
am.
Yes,
Ma'am, you
Miss is
asked.
sharing her screen.
Okay, so 1 second.
So you can see, right?
Yeah, miss, now I can see.
Okay. Oh, okay, so just give me a second. This page got lost. First question.
Miss, your
Which
voice is
has
still
oxygen
black.
and boron. They have given
Ma'am, I can't hear what you're saying.
Yeah, same here.
okay.
Lagging.
Okay, now is it better?
Yeah, miss, much better.
Awesome. Okay, the 31st question. You can see the screen, right? So there is this sample which has oxygen and boron, and they have given you the oh, okay. Somebody joined in. Fine. So they are giving you the weight of boron and oxygen. They are asking you to calculate the percentage of composition of the compound by weight. So I'll show you how to do this question. So you ask you
Miss, still your voice is lagging.
Yes, ma'am.
oh, okay. Is it fine now?
Yeah, miss, now it's better.
Yes, ma'am.
Oh, cool. I'm sorry, I think it's the rain. It's like the internet is really bad. So the 31st question. So they've given you the sample mass. So I'll write it like this. Total mass of the sample is 0.48. Isn't it? 48 gram. Then they have given you mass of boron. What is this? It is 0.192 grams. They are giving you mass of oxygen in the sample. Oops, I should add that. This is 0.288 gram. Okay, so now they are asking you percentage composition. So whenever they ask you percentage composition, what does this word mean exactly? Is basically composition is nothing but it's made up of. So this sample is made up of boron and oxygen, isn't it? So percent composition nothing but how much percent of boron does it contain, how much percent of oxygen does it contain. Did you get it? Whenever you see this term percentage composition, don't get confused or don't have any doubts like what does it mean. It always means they want composition, basically you break the word. So composition is nothing but its constituents, what it is made up of. So this sample is made up of oxygen and boron. So you need to find the percentages of oxygen and boron. So how will you do that? So first one, percentage composition of boron is nothing but 0.192 by 0.48 into 100. So to get percentage, you multiply by 100, right? So that's why. So you will get it as 40%, right? Similarly, you solve for oxygen. So percentage composition of oxygen is nothing but 0.288 by 0.48 into 100. Should be 60. Hint sort of a thing. Check this out. This is 40 and this is 60, right? If I add these two, I'll get 100. Isn't it? Whether the answer is correct or not. See, why is this so? Because this sample only contains boron and oxygen, correct? So it won't have anything else. So this percentage, when you add to 100%. If
Your voice
there's
is
which has
breaking.
3. Oh God. Okay. Just a second. Okay, is it fine now?
Miss?
Yes.
Miss, can you please
I couldn't hear you. Can you please explain?
Ma'am, your voice is lagging.
miss, but wait.
Explain the percentage. Am I audible?
No, ma'am. Yes, ma'am.
Okay. Okay, so one of you wants me to explain the percentage composition again. I'll tell you what it is. Okay.
Ma'am, your network is lagging too much. Means
Yeah.
it's coming
Yes, ma'am.
like your voice is repeating again and again and again. Ma'am, are you there? We can't hear you.
Just give me 1 second. One
Okay, ma'am.
Ma'am, we can hear
Okay,
you.
miss.
second. I'll just try to fix this. Okay. Now it should be better now. Can you? Hello? Can you all hear me?
Ma'am, did you say something before this?
Yeah, ma'am.
No, I'm just asking if you all can hear me.
Yes, ma'am.
Oh, okay. Yes, ma'am. I can
You
hear.
can?
Yes.
Awesome. Okay, okay. Okay. So, you want me to explain the percentage composition again, right? Okay, I'll do that. So basically, just break down these words. Okay, break down these two words, percentage and composition. You know, right? Percentage means you calculate the, you divide the mass or the given number by total into 100 gives you the percentage. Correct? And what is composition? Composition is nothing but constituent, or in simpler words, what it is made up of. Okay, that's what composition means. It is composed of boron and oxygen, or it contains boron and oxygen. Correct? So whenever they ask you percentage composition, you need to take each element or each constituent or compound separately and find the percentage. So like in this sample, it's just boron and oxygen. So you find the percentage of boron and percentage of oxygen, and that's it. That's all you have to do. Suppose they gave you a sample which has three things. Like if they say it contains oxygen, nitrogen, and hydrogen. Okay. Then if they ask percentage composition, you need to find the percentage of each of them. Oxygen, nitrogen, and then hydrogen. All three. Okay. And I was saying, I was giving you a small hint here that in this question, if you add the percentage of boron and oxygen, you get 100%, isn't it? 40 plus 60 gives you 100, correct? And this sample contains only boron and oxygen, right? So it should ideally add up to 100%. So this is one way of verifying your answer. If you've done some mistake in calculation or anything, you can figure it out here. If you get anything below 100%, it means there's something wrong. Okay. So always check that. So the total percentage is always 100%. So all these answers, like in this case, if you were to find the percentage of oxygen, nitrogen, hydrogen, when you add these three, okay, when you add them, you should get a total of 100%. Nothing more, nothing less. Okay. That's just one way of checking whether your answer is correct or not. Okay. Fine. Let's go to the next question. Okay, write the formulae of following compounds crisscross method.
Miss?
Yes.
Ma'am, which screen are you showing? Could you just
Yeah, Miss, I was also just thinking.
I'm showing my question. Can you see it?
Yeah, Miss, now I can see.
Can you see
now
it?
we can
Yes, ma'am.
Okay. Okay. So anybody has any questions in level one? Doubts?
Miss, your voice is lagging. I can't hear what you said.
Just a second. Okay, am I audible now?
Yeah, Miss, now it's better.
Okay, so I was asking, does
Yes, ma'am.
anybody have any questions in level one?
No, Miss.
No doubts in level one?
Ma'am,
Yes.
ma'am, could you just discuss the 16th question once? I just have a small doubt.
Okay, this one. What is the difference between sodium atom and sodium ion? This one, right? The sodium atom and sodium ion one?
Yes, ma'am.
So basically, sodium atom is what? Sodium atom will be. This is what they have asked. Oh. Okay. So sodium atom is Na, sodium ion is Na plus. Correct? So they're asking you the difference between the two. Okay, for this you can talk about its electronic configuration. So do you know the atomic number of sodium?
11.
11.
11, right? So what is it? Nothing
Yeah,
but
Miss.
2
Plus 8 plus 1.
and 1, right? This is how you write the electronic configuration. Correct?
Yeah, Miss.
So this is for sodium atom. For sodium ion, what is it? It's 10
Miss,
because it uses
It gives one electron to become stable.
correct.
yeah,
It loses this electron.
1
So it
electron.
becomes 2 and
10.
8.
2 and 8.
Yes. Correct. Stable octet. Isn't it? So this is one difference. You can say that the sodium atom has 11 electrons, whereas sodium ion has 10. And what is the second thing? It's like clear. The second point will be this has a positive charge. This is charged basically. This is neutral. Atoms are neutral. They don't have charge as such. Ions have charge. Okay. You can use 2 points.
Miss, your voice is lagging.
Oh, can you hear me now?
Yeah, Miss, now it's better.
Okay. Alina, did you get it?
Yes, ma'am.
Cool. Okay, so no doubts in.
Yeah, Miss.
Yes, tell me which one more point.
Sodium ion is smaller than sodium atom.
Okay. Yeah. Okay, fine. You can write that. But for that, you need to know that there's a relation between the size of atom and the shell. So because it has one shell less, that's why it's smaller. You can do that. So, okay, any other doubts in level 1?
No, miss.
No? Okay. Level 2, the first one itself is interesting. In the reaction, 5.3 gram of sodium carbonate reacted with 6 gram of ethanoic acid. Okay, and they've given you the products. Show that these observations are in agreement with the law of conservation of mass. Oh, okay.
We have to add the given quantities as they've given the equation, and then we'll get the answer as 11.3 grams each.
Correct. So you'll do LHS, like you add sodium carbonate and ethanoic acid, and you add ethanoate, carbon dioxide, and water separately. Both should be equal. Right? Anybody has
Ma'am,
any doubt in that question? Yes.
No, ma'am.
ma'am, I don't have a doubt in this question, but I have a doubt in I did not get how to solve 3.2.23.
Yeah, sure. Okay, let's go there. Okay. A sample of NC is known to contain 2.58 into 24 oxygen atoms. Okay, let's do this. Fine. So
Miss, your voice is coming.
first write. Okay. Uh, okay, can you hear me now?
Yes, ma'am.
Yes, it's better.
Better? Fine. So they have given you the sample of vitamin C, right? Sample of vitamin C contains
Mom, we can't see the question.
2.58 into 10 to the power 24 oxygen atoms. Okay, 2.58. And they want you to find out the number of moles, right? Okay. So remember I told you there are two formulas for number
So,
of moles.
ma'am,
Number
we'll
of
be using
particles by
given.
Avogadro's number. Number of particles by
Yes, ma'am.
Avogadro's.
Yeah, Raghav, yeah, tell me.
We'll be using the second formula which Ritvik just said.
Yeah, yes, correct. So you all are right. So in this case, we will be using number of particles by Avogadro's number. Once again, I'll tell you the hint in case you all are finding it hard to comprehend the question. The easiest way is just see if you're given anything, like in this question you are given 10 to the power 24, right? So automatically use the second formula because you will get Avogadro's number and it will get the powers will get eliminated.
Okay, miss.
Ma'am,
Yes.
ma'am, which is the first formula? Can you just write it over here?
Yep, sure. I'll write it at this side. So there are two formulas. Okay, one is given mass by molar mass. Okay, this is one. And the second one is number of moles is equal to number of particles by Avogadro's number.
So, miss, you are using the second one.
Yes, I'm using the second one.
Okay, miss.
This will be 6.022 into 10 to the power 23. You solve, so see, this powers will get cancelled, right? So you'll get something like only 10. So it'll just be 10 here, right? When you divide, you'll get 4.28 more. One more hint here, the number of moles. Okay, number of moles, I'll write it here. Number of moles will be, you know, small numbers or fractions, or sorry, decimals. Let's say decimals. Decimals is better. It won't have 10 to the power 23 or anything like that. That's one way you'll know. Okay. So number of moles is always like smaller quantity. It should be 2 moles or 4, 5 moles, 10 moles, something like that. Okay. Or in decimals. But it will never be something like if you're getting an answer 10 to the power 8 moles or something like that, there is some mistake happening. Just keep that in mind. Okay. Okay. So you got this question? Fine. Let's go back. Anybody else? Few of you said you all had doubts, right? Oh, what doubts did you all have? Tell me, we'll discuss.
Ma'am,
Yes.
ma'am, actually in the question 3.2.5 and 3.2.6, I got confused in where do I have to use Avogadro's number, where should I use the actual molecular mass of the element?
Oh, okay. See, this is what I was trying to explain, like in the beginning of the class. In fact, I did it for this sum also. I'll tell you once again. So why don't you all write this down somewhere? Okay, just write this down, whatever I'm writing in the purple box. Okay. When they give mass in the question, like 16U or 18U or something like this, in U is given, use first formula. Okay. And when you have 10 to the power something in the question, like 23, 10 to the power 23 or 24, like this question, use second formula. Okay. Use this like a, I
Miss,
don't know. Tell me.
Miss, can you please repeat what you said right now? Because there's some internet issue here.
Okay, I wrote it down here on the board. It's in this purple box. This is what I was saying.
Okay.
Okay, so use this like a cheat sheet kind of a thing. Like when you are really stuck and you don't know which to use, refer to this. Okay, this will help you.
Yeah, Miss. Are you going to upload this one, this class?
Yeah, yeah, I will definitely be uploading.
Okay.
Okay, so like in 3.2.5, it says 1 mole of carbon atom weighs 12 grams. So it's given in grams, right? So, okay, I'll write it here in U or in grams, any of these. Okay. Use the first one. So it says it weighs 12 grams. What is the mass of one atom of carbon? So how will you do this? Okay, I'll show it to you. 3 point. Okay, so 1 mole of carbon atoms what have they given you? Weighs 12 grams. Weighs 12 grams, correct? They have given you this. So now they are asking you what is the mass of one atom of carbon? Okay, mass of one atom of carbon. Okay, so if I translate this sentence, this first one, it says 1 mole is 12 grams C atoms, correct? But we also know 1 mole is 6.022 into 10 to the power 23 atoms. Correct? We know this. This is the definition of mole. So I'm going to use simple unitary method here. So if 12 grams is this, then 1 gram is how much? So I'll just do unitary method. I multiply this, so it will become 6.022 into, oh wait, this will go in the denominator. This will be 12
Miss,
wait, huh? Yes.
Miss, I just had a general doubt that in some textbook it is given 6.023 into 10 to the power of 23, and in some it is given 6.022. So which is the correct one? 0.22, right?
Both are correct. You can use anything.
Okay.
Okay, they've asked you one atom, not 1 gram. No. So there'll be 1 here and X here. Array, making the same mistake again. Yeah. They've asked you mass of one atom. So this will be X here. So it will be, yeah. So now it's correct. It will be 12 by 6.022 into 10 to the power 23. This will be your answer. So notice here it is they are asking you mass. It's not moles because it is mass. It you will get the answer something to the power. This will go this will become 10 to the power minus 23, isn't it? You'll get something into 10 to the power minus 23. This is correct because it's mass. They asked you moles and you're getting this means there's something wrong. Okay. So this is how you do 3.2.5. You got it right. What did I do? I've just used unitary method, nothing else. This did not have a mole calculation, so neither of the formulae were involved. Just because they have asked you how many atoms are there and they have given you mole. Correct? Okay. Fine. Then what is the other question? 3.2.6. Which has more number of atoms, 100 grams of sodium or 100 grams of iron? How will you do this? This again I think will be a two-step question.
I think we have to find the amount of moles in the then we can.
Correct. Yeah, you can do that. So you can do this by like two steps.
Ma'am, we have been given the mass. We can do it the actual mass, and then we can find the number of moles, and then number of moles equals to uh, atoms. So we can multiply the number of moles.
Correct. Yeah. So this will be like a two-step. So in the first step, what will you do? Okay. So here they have given you mass. So I'll write it like this. Given mass of sodium is 100 grams. Correct. And iron also is the same. Correct. Yeah. And given mass of iron is also 100 gram. Correct. So now this is what is given. We need to find. So let me consider the case of sodium first. So what will I do? I'll find the number of moles, which is nothing but given mass by molar mass. They have given you both in the question. It should be 100 by 23, correct? So you'll get some answer here. And similarly, do the same for iron. Okay, wait, I'll do the complete thing for sodium, then go to iron. Okay, so what will I get if I do 100?
From the mass of sodium is
I'll get 4.347 something. Okay, So now what do? I use the second formula. Now I have number of moles is equal to number of particles by Avogadro's number. So I have this and I have this. I don't have number of particles. That's what I need to find, isn't it? Number of atoms. So what will I do? Number of what has more number of atoms, correct? So I can write it as number of atoms is equal to number of moles into Avogadro's number, isn't it? Now what do I get? I get 4.347 into 6.022 into 10 to the power 23. That will be your answer. Fine. Similarly, you do the same for iron and you compare this answer. Okay, compare this answer which you get here. Let me say x. Compare this x and compare the answer for iron. See which has more. Okay, that will weigh more. Got it right? Or do you want me to solve it? You want me to show it to you for iron also?
No, miss, I understood.
Okay,
Ma'am, can we
cool.
round up 4.3.347 to 4? We can just round it off, right?
Uh, I don't know. I wouldn't suggest doing that because okay, if you feel calculations are tedious or something like that, uh, stop at 4.3. Keep one decimal point. Don't remove all of them. You keep stop at one decimal point and try solving. That should be fine. The ideal way of solving, I mean, whenever you solve, ideally you need to keep up to two decimal points. But if it's too difficult, you can stop at one. That's fine. No problem. Okay, so this was the sixth one. Okay, we did this seventh one. Oh, it is acha, it's different. Okay, so you got percentage composition also, right? How to do it? Okay, convert into mole. 12 gram of oxygen gas. Interesting. So they are asking you oxygen gas. So it will be O or O2. I'm talking about the ninth question. They are asking you to convert into mole. So the
Ma'am,
first subpart is sorry.
the answer is 0.375.
No. I was asking whether you'll take oxygen gas. They are saying so. Will you be considering O or O2? What happened? Nobody's answering. Okay, my question is, if I'm saying oxygen gas, what will be the formula? Will it be O or it will be O2? Or
O2.
will it be O3?
O2.
O2. Okay. O2. Okay. Anybody says O?
No, ma'am, because it's a gas. Gas is
Yes,
always
ma'am,
O2.
because it's a gas, so it can't be O.
Okay. Cool. So you got it right. So if they ask you questions like this, be careful what you have to take. Whether you have to consider the elemental form, whether you have to consider O2. Yes.
Ma'am, we will divide 32 by 16, right? 16 by 32, right? Or 12 by 32, sorry.
Uh, yeah, it will be 12 by 32. Okay. So convert into mole means what? They basically want you to find the number of moles. Okay. So you use the first formula. First formula is nothing but where is it? It's here, right? Oh, okay, it's no here. Yeah, here it is. Given mass by molar mass. So given mass is okay. I'm just doing it in rough here. So given mass is 12. What is the molar mass? It will be
30.
32.
30. 30.
Correct? 2 into 16. Remember that. So then it will be number of moles will be uh, 12 by 32.
0.375.
Okay. Yeah.
Ma'am, which question is this?
This is the ninth. Wait, let me check. Yeah, ninth one. 3.2.9. And what if they ask you the 3.2.10th? Again, what is the mass of 0.2 mole of oxygen atoms? Now here they have specified oxygen atom. So you will take only O. You will not be
Ma'am,
taking O2.
we can take we have number of moles we can which will be equal to a given mass upon actual mass. So actual mass we can multiply by number of moles to find the mass of oxygen atom.
Yes. So again, you use the first formula itself. That's why I said this whole concept actually has only two formulae, nothing else. So just these two itself, you twist and turn and you get all the answers with that. So use this formula only again, given mass by molar mass or given mass by molecular mass. If you all feel it's difficult to remember molar mass, no, just write it as molecular mass. It's the same thing.
Ma'am, we have to multiply 0.2 by 16, right?
What? Just a second. Yeah. So it will be, so for this is the ninth one. The first part I solved. For let's say the 10th one, let me solve the first part. It will be like this. So number of moles is equal to given mass by molar mass. Correct? So they have given you number of moles, which is 0.2. Correct?
Yes.
0.2 is equal to x by, it is oxygen atom, so it will be 16. So given mass x will be nothing but 0.2 into 16. Correct.
3.2 grams.
0.2. Yes, correct. Okay, that's done.
Ma'am, we can't hear you.
One. So I was talking about the 12th question. Find the ratio by mass of the combining elements in the following compounds.
Miss, your voice is lagging a bit in between.
Ma'am, can you repeat your question?
Okay, I was, yeah, the 12th one. Find the ratio by mass of the combining elements in the following compounds.
Ma'am, can I answer the first one?
Yeah, sure. Tell me.
Ma'am, so we have to split. So we have CaCO3 that is made up of three
Okay.
elements, that is calcium, carbon, and oxygen. So we'll first so calcium atomic number is 40, atomic mass is 40, carbon is 12, and oxygen is 16. Now oxygen, there are three atoms, so we'll multiply it by 3. So 16 into 3 is 48. So 40 is to 12 is to 48, and
Correct.
then we'll simplify it.
Right. Correct.
So can I answer?
So basically, yeah, sure. Tell me.
Ma'am, can I answer
MGC
the next
also.
one?
Yes. Why not?
Ma'am, the next one is magnesium chloride. So there are two elements which is magnesium and fluoride. So it magnesium's thing is 24 is to 35.5 because fluoride has the value, and we'll multiply it by 2 because it's written like Cl square. So we'll have to multiply. So we'll get 24 is to 71.
Ma'am, can I answer for the third one?
clearly.
So the molar mass of hydrogen is 1 gram and the molar mass of sulfur is 32 grams. And for oxygen it is 16 grams. So the ratio by mass will be 2 ratio 32 ratio 64.
Correct. So you all got it right. Anybody? I'm happy you all answered. So I'm assuming like most of you understood this question. So if it's CaCO3, you split it. Okay, it's CaCO and 3. So this is 40, this is 12, and this is 16. Correct. So to be 40 is to 12 is to there are 3 atoms. So 3 into 16. This will be your ratio. Yeah, you can simplify it, of course. Okay, this is how you do the question. Okay, okay, they want to give you the formula. Okay, nice. This one. Calcium chloride is when dissolved in water dissociates into its ions. Okay.
From which question?
Calculate the number of ions. Okay. The 15th one. So calcium chloride, when dissolved in water, they have given you the equation. What happens? Basically, it dissociates. So they are asking you to calculate the number of ions obtained from CaCl2 when 222 gram of it is dissolved in water. Okay. Anybody
Ma'am,
wants to try?
ma'am.
Yes.
So
Yes.
I have a way to solving this sum. So CaCl2 has 1 mole, Ca has 1 mole, and Cl has 2. Now, sorry, one second.
Mm. Okay. Anybody else wants to try?
Ma'am,
Yes.
yeah. So first we'll find the number of moles. So given mass upon mass of CaCl2, so that is 222 upon 111. Why? Because calcium is 40 and Cl is
Correct.
35.5. So if we multiply it
So
by,
it will be 70.
so it'll be 71. So 222 upon 111. So CaCl2 will be 2 moles. Now if 1 mole of CaCl2 gives 3 ions, because Ca is 1 ion and Cl is 2 ions, so that will give us 3 ions. Then 2 moles will give us 6 ions. So 6 into Na, that's the Avogadro's the formula. Then 6 into 6.022 into 10 to the power of 23 will be 36.022 into 10 to the power of 23. That will give us 3.6022 into 10 to the power of 24.
Correct. Awesome. Okay. So I'll just quickly show it to you for the rest of you. Okay. I'll show you how to do this, what they have done here. Okay. So let's go stepwise. They have given you an equation, correct? They have given you an equation saying that CaCl2, okay, dissociates into calcium, valency 2 plus and 2 chlorine, correct? This is the balanced chemical reaction, correct? So now if I'm considering this, okay, let's say this is the compound basically, right? And these are the ions, isn't it? So now they are directly asked you to give the total number of ions. How many
Miss,
would
your
be the
voice
mole
is
of
lagging.
the
Ma'am, I can't hear you.
Miss, your voice is lagging in between.
Can you hear me?
Yes.
Yes, ma'am.
So I was saying they have directly, like total ions.
Ma'am, it's again lagging.
Look, can't-
Again,
It is
lagging.
again lagging.
okay, give me a second. Now, can you all hear me?
Yeah, now better.
Now better, ma'am.
Okay, okay, fine. So yeah, I was. Oh, what happened to my whiteboard?
Ma'am, in this question we will multiply 111 by 2, right? Because it's CaCl2.
Huh, correct. Okay, just a second. Why is this hanged? Huh. Okay. I'm sorry, my whiteboard seems to be hanged. Okay. Hmm. So coming back to the question, basically what they are asking is calculate the number of ions. Okay. So here be careful. They haven't asked you directly from the equation how many ions they have got. They are asking you in terms of this. Oh, wow. Okay, it is still hanged. Oh God, just give me a second. Okay, CaCl2 dissociates to give you Ca2 plus and 2 Cl minus ions. So here they have asked you number of ions when 222 gram of CaCl2 is dissolved. Okay, this is this is 222 grams. Okay, so now what they are saying, they have given you the mass as, so this is nothing but given mass will be 222. So number of moles will be given mass by molar mass. So this is nothing but 222 by, so I'll write it separately for calcium 40 plus it's 2 atoms of chlorine combined, right? So it will be 2 into 35.5, correct? So this will be nothing but 222 by 111. This gives you 2 or 2 moles, correct? Okay, so but here this equation shows that 1 mole of CaCl2, right? Why am I saying it's 1 mole? Because there is nothing here in front of CaCl2, correct? So it will be 1 mole. If there is no number, we consider it as 1 mole. 1 mole of CaCl2 is giving me 1 mole of Ca plus ions. Okay, I'm writing it in uh, green here. And 1 mole of, sorry, and 2 moles of Cl minus ions, correct? So basically the total ions I'm going to get will be 3, correct? Total. Now we are considering this situation. This is before we took 222 grams. Now since they are saying it's 222 grams, which means there is 2 moles of CaCl2. I have doubled the amount, which means what will I get? Which means I'll get 2 moles of Ca plus, correct? And I'll get 4 moles of Cl minus. Correct? Isn't it? Basically, what they have done is they have changed the equation to this. The equation becomes this. 2CaCl2 is giving me 2Ca2 plus 4Cl minus. Correct? This is what the equation will be if I am saying we are considering 2 moles of CaCl2. Okay? Hence this comes to a total of 6 moles. Isn't it? The ions. 6 moles of ions. Correct? So what will I do now? Next step, I use the second formula, which is number of moles is equal to number of, in this case, I need to find ions. So number of ions by Avogadro's number. Correct? So it will be number of ions is equal to number of moles into Avogadro's number, which will be 6 into 6.022 into 10
So 10 to the
23.
power 23.
Yes. So you get the answer.
Now we can multiply 6 by 6.02.
Yes, correct. So that's how. So I hope it's clear why we are considering 6, why we are multiplying by 6. You got that, right? Anybody has any confusion in that?
No, ma'am.
No?
No, miss, not at all.
Awesome. Okay, any other question you have a doubt? Let me know.
Miss,
No, ma'am.
Yes?
miss, the class is till 4:30, right?
Yes.
Okay, I thought it is still fine.
No. Still 4:30. Okay, and all these MCQs, which of the following correctly represents 360 gram of water?
2 and
Miss,
4.
So for this,
D.
Which question?
the 17th one, which of the following correctly represents 360 gram of water? What will you
Ma'am,
do?
2 and
You
4.
calculate. Huh. Acha. So for this, basically you do this. So you do number of moles is equal to, so given mass is 360, correct? 360 gram of water, and since it's water, it will be 1 plus 2 into 16, or basically 18. 360 by 18, correct? So this will give you 20. Moles. And then what do? You do 20 is equal to number of atoms by Avogadro's number.
So 20 into
Yes. Number of atoms is equal to 20 into 6.022 into 10 to the power 23. And this will be something like 12 point something. Yeah, 12.20.
12.044.
yeah, miss, so answer is D.
Yep. So this will be 24th.
1.2044.
Correct. So you calculated both ways. That's how you get for this MCQ. Basically, you use both the formulae and calculate. Okay. Same for the 18th one also. No, 18th one you just need to do it once using the first formula.
Yeah, miss.
Ma'am,
Yes.
ma'am, could you just explain that previous sum? Actually, there was some issue with my net, so.
Yeah, sure. So this question, the 17th one, they have asked which of the following correctly represents 360 gram of water. Okay, and they have given you options both in number of moles as well as number of molecules. Correct? So, okay, yeah, I can change this to number of molecules. So basically, I was saying you need to solve using both the equations, both the formulae which I had mentioned, So while using the first formula, you will get the number of moles. Then use that number of moles in the second formula to arrive at number of molecules. Correct? And that's how you'll know which are the correct options, because there is one correct option for the number of moles and there's one correct option for number of molecules. Okay, and similarly for the next two also, like which would weigh the highest, you need to find out, you need to solve each option using the first formula. So they are giving you the number of moles and you can calculate the molecular mass. So you will get the given mass, correct? So from the given mass, whichever has the highest given mass will be the correct answer. And what about the 19th one? 19th one, what do? You need to solve using both the formulae. So they are given you mass. So again, it will be like the one I just showed it to you. You find the number of molecules, then use, you find the number of moles, then use that number of moles to find out the number of atoms. Correct? Okay. Same thing for the 20th one. Okay, similar principle they are all on. Okay, any other doubts?
No, ma'am.
No. Anybody having any doubts, you can let me know.
No doubts, mates.
No doubts? Nobody? Everybody's clear? All the sums
Yeah, miss.
for the homework? And what about mole concept? Are you clear with it now?
Yeah, miss. Now it's clear.
Clear? Okay. What about the rest of you? No doubts? Or do you have anything?
No.
No? Okay. Okay, then let's finish the class since you have no doubts. So try for this chapter at least, try solving maximum questions which are pertaining to mole concept. Okay, because that's the most important part of this chapter, right? So keep solving those kind of questions, and in case you have any doubts, you can ask on the group, or you can ask me or Lasya ma'am, anybody. Okay. Okay then. Bye.
Thank you, ma'am.
Okay.
Thanks a lot, miss.
Bye.
Miss, you will be uploading by today or tomorrow?
I'll upload it right itself. Let me see.